All right, in this video, we're going to be reviewing the Pythagorean theorem, and the Pythagorean theorem is used to find the lengths of the missing side in a right triangle. So this is only for right triangles. Now let's review our pieces of the right triangle. The two sides that form the right angle, those are called legs. This is a leg and this is a leg. And the side opposite the right angle is the hypotenuse. And remember, the hypotenuse is also the longest side. So that'll help you in the multiple choice questions to decide which one might not be an answer. So if it's ACT prep here, we want to make sure we're eliminating answer choices if we can. So back to Pythagorean theorem. You have probably seen it as a squared plus b squared equals c squared, where a and b are your legs. So let's go back over here and label that a, label that b, hypotenuse, and c. But sometimes I'll write it like this because leg squared plus leg squared equals, those are just parentheses, hypotenuse squared, because sometimes we don't use a, b, and c as our unknowns. So I want you to understand that it's leg squared plus leg squared equals hypotenuse squared. But most commonly, a squared plus b squared equals c squared. It's the same thing. All right, again, only for right triangles. Let's take a look at an example. So here's our right triangle ABC, and we want to know what is the length of leg AC in the triangle shown below. So we didn't put a variable here on this leg. You could put anything you wanted. We'll just put an X because it's pretty common for your unknowns. You could make it A or B, but it would be lower cases. Remember, when we reviewed triangles, we labeled those sides by lowercase letters and the angles by the uppercase. All right, so leg squared plus leg squared equals hypotenuse squared. We just want to plug this into the Pythagorean theorem. X squared plus 5 squared equals the square root of 89 squared. All right, and then we just start simplifying this. X squared plus 5 squared is 25. 5 times 5. You want to bring your calculator on ACT day. And then here, we're squaring a square root, so those actually cancel each other out, and you're just left with 89. Trying to solve here for x, so it's just like solving any other equation. We want to isolate the variable, so we have to subtract 25 on both sides. The 25's cancel. X squared is equal to 89 minus 25 is 64. And we're not done yet because we're solving for x, not x squared. So to undo the squared, you take the square root on both sides. So we'll square root both sides. Squared and square root cancel, leaving me with x is equal to square root of 64 is 8. So the length of leg AC is 8. All right, I've got one more Pythagorean example for you. And this one has got two unknowns. It says find the length of the missing leg and hypotenuse. And there's a lot going on here with this triangle that I want to point out to you. First of all, it doesn't have the little right angle symbol that we're so used to seeing. And so we have to figure out that, yeah, it is a right triangle because this angle is 45 degrees right here, and this angle is 45 degrees. 45 and 45 makes 90 degrees, and the sum of the angles in a triangle is 90. So since this makes 90, all you have left is 90 degrees. So we know this is definitely a right triangle. Okay, so it doesn't have to just be 45 and 45. It could have been 30 and 60. Okay, but we know that that has to be 90 degrees because all three angles add up to 180. All right, so let me erase those circles. Now we have two unknowns, and so if we try to plug that into the Pythagorean theorem, then we get leg squared plus leg squared equals hypotenuse squared. And that's not going to work because we have two unknowns. So we have to go back to the idea that this is 45 degrees and 45 degrees. And as you remember from a previous video, that makes this an isosceles triangle because those are the base angles. And so when the base angles are congruent, the opposite legs are congruent. So we have no math to do at all. We know x is 4 because the base angles are congruent. Let me write that over here too. Okay, so that changes it up. Now we should be good to go. So what if I just erase that? Get my pen again, and we know what x is. It's 4. So now we've got leg squared plus leg squared equals hypotenuse squared. We only have one unknown, so now we're good to go. 4 squared is 16 plus 4 squared is 16 equals y squared. 16 plus 16 is 32 equals y squared. And to get rid of the squared, we take the square root on both sides. The squared and the square root cancel. Y is equal to the square root of 32. Well, that's not a perfect square, but we can do some more work with it. We want to simplify that radical, which we also reviewed in a previous video. So let's go over here to the margin and talk about our factors of 32. Okay, if we just don't know our factors and we get kind of stumped, then we can just start with the lowest number. We can do 1, but that doesn't really get us anywhere because we already know 32 is not a perfect square. So really we kind of just start with the 2. And 2 goes into 32 16 times, and 16 is a perfect square. So I'm going to stop right there and think about the square root of 32. Again, this is just some margin work, as the square root of 16 times the square root of 2, and the square root of 16 is 4. So this becomes y is equal to 4 square roots of 2. Always want to simplify those radicals, but what you also want to do on the ACT, just double check your answer choices because you don't want to start simplifying your radical if the answer's there. So you don't want to spend your time doing extra stuff when the answer might be as a decimal, or they may have left it a square root of 32. But my bet is they would simplify that radical. Okay, Pythagorean theorem only for right triangles.